All right, so here we're going to have 4.1 part 2. We're going to start looking at piecewise functions. So I'm going to look at two examples here, and in the process, I'm going to show you where the author does things, and then I'm going to show you what I think you should do to make your life easier. So here again, I talked about piecewise functions with those absolute value equation. Now this piecewise function is made up of three different functions. So if again, going back to 3.4, negative 2x plus 1, x to the first, this is linear. Just the number 2, that's a constant function. X squared is quadratic. That's going to make a straight line, horizontal line, parabola. All based on what x's I can use. So everything after the 4 here is my domain restriction. All right, so the first thing the author says is that you have to be capable of evaluating piecewise functions. So we're going to find f of negative 1, f of 3, f of negative 2. Again, those are the x values. So what we do is you take the negative 1 for your x and you see which of these three domain restrictions will be true. That's what we're going to do. So we'll test them. All right, so negative 3 less than or equal to negative 1. That's true. But negative 1 is not less than negative 1. So this is false. We're not going to use this one. Check the next one. And the next thing you'll notice is that these are traditionally in numerical order. Smallest x is at the top, largest x is at the bottom. Is negative 1 equal to negative 1? This is true. So since this is true for this domain restriction, we use this function. All right, so that's going to be a 2. Really can't substitute a negative 1 in because it's a constant. You just give the constant value. All right, if I want to find f of 3, well, 3 is bigger than negative 1, so this inequality doesn't work. 3 is not equal to negative 1. 3 is greater than negative 1. This is true. So we're going to use the quadratic function and plug the 3 in for that x. So 3 squared is 9 minus 1 is 8. There's my answer. Now we're going to use negative 2 for x. Okay, so since it's negative, we want to go probably check the first one because that's where we have our smaller x values. Negative 3 is less than or equal to negative 2. True. Negative 2 is less than negative 1. True. So this is the inequality that makes true. We don't even have to test the other ones because when one is true, the rest are null and void. Okay? So negative 2, we're going to put a negative 2 in for that x. So negative 2 times negative 2 is going to be 4. Plus 1 is 5. Again, recall the definition of a function. Since you have function notation, for every x, there will be exactly one y coordinate for each answer. All right, so if you accidentally forgot how to do these, don't take the negative 1 and plug it into all three of these functions and give me 3 answers. You will get absolutely no credit because you are violating the definition of a function. Well, speaking about the domain, what is the domain of this function? As I said, standard practice, these are in numerical order from top to bottom. So I'm touching negative 3, and I touch all the x's to negative, I don't touch negative 1, but I do touch negative 1 here with the equal sign, and then I want everything to the right of negative 1. So if I look at this x-axis, here's negative 3, I can touch it. I can touch, even at negative 1 I touch, and then I touch everything to the right. So my domain would be bracket, negative 3, comma, infinity in interval notation. So again, you can get that answer right here from the domain restriction. Smallest to largest, this next number should be in the next domain restriction. The biggest number here should then be in the next domain restriction. All right, part 3. Find all the intercepts. This is where I begin to get frustrated with the author again. We have to find x-intercepts and y-intercepts. Well, the easiest to find first is the y-intercept because that's when x is 0. So that's like doing number 1 again, but you have 0 in here. So 0 makes the last inequality true. 0 is greater than -1. We put 0 in for x squared, that's a 0. 0 minus 1 is -1. There's my y-intercept. That's the easy part. And of course, as I mentioned before, the author always uses easy functions to work with. Because now when you want to find the x-intercepts, now you have to set all the functions equal to 0 and solve them individually and see if your answer for x fits in the domain restriction. And if it doesn't, all the work you just did goes for naught. See, that's what rubs my rhubarb the wrong way. I can't stand doing wasted work. So the author says, okay, take the first function, set it equal to 0. Solve for x, subtract over the 1. Divide by -2. X equals 1/2. Wait a minute. 1/2 is positive. That's nowhere between -3 and -1. Wasted work. Okay, it's linear, not that big of a deal. But what if that was a crazy, ugly function, a crazy quadratic, and it took me a while, I had to do the quadratic formula or whatever to solve it? I'm going to be irritated if I throw it all away. Second function is 2. Set it equal to 0. Wait, that's false. That's not true. That's not going to work. Okay, let's go to the last one. X squared minus 1 equals 0. Add over the 1. Okay, take the square root. X equals positive or -1. Okay, check the domain restriction. Oh wait, -1 is not greater than -1. That doesn't work. But +1, wait a minute, +1 is greater than -1. The +1 is okay, but the -1 violates the domain restriction. So our x-intercept will be 1, 0. And there's my x-intercept. To me, this could be annoying to do work where you had 3 crazy functions and 2 out of the 3 don't work. That could be some serious wasting of time. We'll fix it in another example and how we really should do these problems. Step 4, my next part of using the piecewise function, graph the function. Now the author says, well, here's what you should do. Since the first function is a linear function, technically you only need 2 points to graph a straight line, which is true. So just test the endpoints, except for the -3. When you graph that point, it's going to be a closed circle. And when you graph the -1, that will be an open circle. Okay? Now, I'm going to color code these: red for the first, green for the second, blue for the third. So, -2 times -3, that's a +6, plus the 1 is 7. There's the first endpoint. Then test the -1. Just remember, this will be the open circle. -2 times -1 is a +2, plus 1 is 3. So the point -1, 3. So let's graph those. This one's closed. 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, closed. Because of that equal to line again. This one's open. -1, 3. Open circle. Draw a line connecting them together. Now remember, the -2 being multiplied to your x, that's technically an mx plus b format. So if you wanted to plot an extra point, down 2, right 1, to help you graph it, so be it. But that's the first function's graph based on this domain restriction. So graphing the second one, well, if it's just x equals -1, there's only one x you can have. This is going to generate just a point. So when x is -1, your y-coordinate is 2. That gives us the point -1, 2. We graph it, and the second one's done. The third one, this is where I'm really thinking the author's lost his noodle. He says, okay, start at -1. Remember, this will be an open circle because of no equal to line. And test it in the function. And then test -1, 0, 1, 2, 3, 4 until you run out of graph. So we plug in the -1, we square it, that's +1, -1 is 0. Okay, first point's at -1, 0, right here. But again, open circle because of no equal to line at the -1. Now, test 0. Put 0 in for x squared, that's 0, -1, -1. There's my 0, -1. Oh yeah, that's right, that was my y-intercept. Boom, there's the point. Now test +1. Well, it should be the same as what we had over here because -1 squared is 1 and +1 squared is 1. 1 minus 1 is 0. Boom, 1, 0, there's my point. Now we'll test the 2. 2 squared is 4, minus 1 is 3. That's the point 2, 1, 2, up 3. Plot that point. Next we'll test the 3. 3 squared is 9, minus 1 is 8. That's the point 3, 8. Well, this should fit. 1, 2, 3, 4, 5, 6, 7, 8. There it is. So now I'm not going to test the 4 because I'm going to be off the graph. It's going to be too high. So here's my U parabola shape right there. Okay? Now the graph is done. Number 5, use the graph to determine the range. Okay, well the domain was done with a domain restriction. The range, you literally have to graph it. So we'll start, again, take your pencil or make a horizontal line, as a horizontal line down here at the bottom. All right, indicate the very first y that you can touch, it's -1. And then we're going to slide this going up, and we're touching, still touching the graph. Touch, 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 still touching. Touch, 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 all the way up to that arrow, which means we're going up to infinity. So my domain would be bracket -1, comma, infinity. Number 6, is f continuous on this domain? No, there's breaks in the graph. It skips, it jumps. We're not continuous. So that's a big no. All right, now let's go back and imagine we had this graph here. Remember we were asked to find f of -1, f of -2, f of 3, I think it was. That would be much easier if we had the graph. F of -1, go to -1, go up, hit the point that's closed. Okay, y is 2, -1, 2. F of -1 is 2. What was that? Let's see, what was our other one? F of, what was it, 1 or -2? Here's -2, I go up, bam, there's my answer. 1, 2, 3, 4, 5. There's f of -2. F of 3, 1, 2, 3, 4, 5, 6, 7, 8. There's my point. So it'd be quicker to evaluate these right off the graph. Oh, wait a minute. Here's a big time saver. X-intercepts. Once you have the graph, can I see where it crosses the x-axis? Yeah, it's right here at 1, 0. I don't have to test the first function, second function, or third function. I can see it right here. The only time I would set a function equal to 0 is, let's say my x-intercept was in between the tick marks and I wasn't sure exactly where it's at. Now I'll have to go solve it by hand and find the exact valued answer. So I think what you should do, whenever they ask you to all these questions to a function, always graph it first. Okay? So, second example, here we go. New piecewise function, of course. Now we get to the homework, and now the functions are more tougher. All right? The difficulty has gone up. But again, notice your domain restrictions. Start with the negatives, work up to the positives, small to large. -2, -2 to 1, start at 1. So let's graph this. All right, now you remember the author said, well, test points. I'm going to have to start at -2, and then -3, -4, -5, -6. So I made a table. I did all this number crunching because I'm so smart, and I found my answers. So the point -2, 1, plot it. -3, 4, plot it. -4, 5, plot it. -5, 4, plotted. -6, 1, plotted. All right, start at -2. It's a parabola that opens down. Okay? Then my absolute value functions from -2 to 1. So I'm going to test the integers. -2, -1, 0, 1. Put in the numbers, crunch them all out. First point's -2, 1. Hey, wait a minute. It's the same point. That's fine. We'll just put a circle, an open circle around the closed circle. Then we're at -1, 2. Okay, -1, 2, plot the point. 0, 3, plot the point. 1, 4, plot the point. We're done. Now, so we know absolute value is a v function because we saw that in the last video. But, okay, this is all I have. It's just that one side of the v, so it must be coming down and bouncing up over here somewhere on the left. But we can only use those x's. All right, so my next function here, the square root of x minus 1. Now I'm going to pick x's that definitely give me perfect squares so I can take the square root. So I'm going to test the 1. Boom, 1 minus 1 is 0. The square root of 0 is 0. I can plot that point, but again, no equal to line. It's open. Then I'm going to pick 2 because 2 minus 1 is 1. The square root of 1 is 1. Perfect. I can plot that point, 2, 1. Then I'm going to pick a 5 because 5 minus 1 is 4. So I don't want to test 3 or 4. 3 minus 1 is 2. 4 minus 1 is 3. I can't take the square root of those numbers. But 5 minus 1 being 4, I can take the square root of 4 is 2. So at 5, I'm at 2. I'm going to run out of graph. There's my graph. Everything's graphed. Okay? Now, if you believe me for 1 second that I did this all by hand, you crazy. No, 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 no. Here's going to be a cool feature of the calculator. You can enter this into Y1, and instead of graphing it, you can actually create this table. You can pick your x's and tell it which way to count, and the calculator gives you the y's in the table. So I typed in the first function, negative parentheses x plus 4 squared plus 5. All right, then I'm going to go to table setup. That's second window on your calculator. You get table setup. You tell the table where to start, -2. And now we want to count to the left. So this little triangle table, that means what's the change in your table? Are you counting up or are you counting down? Well, we're counting down by ones. So I change that to a -1. Make sure the auto are always highlighted because that means the calculator does all the work. You put it on ask, that means you have to put in the work and type it in, and I don't know any crazy person who'd want to do that. All right, now hit second graph, and it creates this table. All right, there's my -2, 1, -3, 4, -4, 5, -5, 6, -6, 1. I didn't do any number crunching. The calculator did it all. All right, so again, let me bring my calculator over. Again, just to show you the buttons that I'm pushing. All right, so y equals, that's where we typed it in. Let's see, x plus 4, parentheses squared. What do we have, plus 5, I believe. Yep. Then we go to second window for your table setup. You can change this to where you want it to start. And again, that's going to come from your domain restriction. Start at -2, enter. And I want to count backwards by 1. So I don't want it to be a positive 1. I make it a negative 1. And then I just hit second graph for the table. And there's all my values that I can go plot. Now, of course, the table is going to give you more than you need. You just have to fit what's ever on your graph. All right, so there's the button pushings. Second one, same thing. Absolute value. All right, this was an old 83, so you might have an older calculator, an older 84. Your absolute value looks like this. ABS left parentheses, put in the x plus 2, close them, plus the 1. The newer 84, as you saw in the previous video when I was doing absolute value equations and checking, it'll give me the bars and a text box in between to type in the x plus 2. All right, but now we want to start at -2. That's the same, but we don't want to count down. We want to count up. So again, second window for table setup, and now change your -1 back to a +1. Hit second graph, and there's my -2, 1, my -1, 2, my 0, 3, my 1, 4. That's as far as I want to go based on my domain restriction. -2, 1 is the open circle. Everybody else is closed. The square root of x minus 1. Okay, so I go to y equals. I clear it out, y1. Hit second x squared to get the square root symbol. All right, older calculators put them in parentheses, x minus 1. Newer calculators, whoops, come back here. The newer calculators will put that inside the square root with a text box. Now, here we want it to start at the 1. So again, second window, table start at 1, and you still want to count by 1s. Second graph for your table. Now, like I said, I didn't choose 3 and 4 because those are decimal y's. Those are tough to graph. So I chose the 1, the 2, and the 5 because they gave me nice integers for the y to graph. And that's how I found all the table values. We don't plug and chug anymore. We're past that. We work smarter, not harder. All right, so that's how we graph it. Now, like I said, we go back to question 1 with the graph. F of -2, I go to -2, I go up, bada bing, bada boom, it's a 1. F of 5, I go over to 5, 1, 2, 3, 4, 5, up 2, answer's 2. F of -1, there's -1, up to the graph, 2, there, I'm done. Don't get me wrong, you can still plug it in. -2 is less than or equal to -2, we plug it in and we crunch the numbers. You get the 1, just like we said. Take the 5, okay, plug it into this function, the green function. 5 minus 1 is 4, the square root of 4 is 2. Or just read it off the graph. F of -1, oh, okay, -1 is somewhere between -2 and 1. Plugging it into the absolute value graph. Oh, or go to -1, go up and hit 2 and say you're done. -1 plus 2 is 1, absolute value was 1, plus the 1 on the outside is 2. I don't know, I think the graph is much easier and quicker. That's just me. Number 2, what is the domain of the function? I can look at the domain restrictions, or I can make a vertical line and say, oh, look, infinity, I'm still touching, still touching, still touching, still touching, still touching, oh, to infinity, all real numbers. X is less than -2. What's the smallest? -infinity. I touch the -2. I start after the -2. I touch the 1. I start after the 1. And I go out to positive infinity. But again, I mean, a picture's worth 1,000 words. Number 3, find all the x-intercepts. Okay, y-intercept. Well, right there at 0, 4. X-intercept, right there. Ooh, that doesn't hit a tick mark. Oh, let's look at this x-intercept more closely. It's on the red graph. That's the first one. This is the one I have to set equal to 0 and solve for x. I don't have to solve any other function. Yes, I just saved myself some time. All right, so as we did the first function, I set it equal to 0. I start to solve for x. Now this is cool because there's only one x in the equation. Just undo what you see. Start on the outside. Get rid of any adding or subtracting. Subtract over the 5. Get rid of the multiplication of -1. Divide the -1 over to the -5, make it a +5. Undo the power of 2, take its square root, plus or minus the square root of 5. Now I'm inside the parentheses, get rid of the +4, subtract it over. I like to sneak it in front of the plus or minus on my square root. So there's my 2, wait a minute, that's 2 answers. I only needed 1. Oh, wait a minute. This is -4, then I go to the left. So that's minus the square root of 5. The plus square root of 5 would be as if this function continued and crossed right in this spot. So we're only going to take the -4 minus the square root of 5, comma 0. That's my x-intercept. Like I said earlier, y-intercept is at 0, 3. I can just visually see that. We're good to go. Number 5, range. Okay, I got my graph. Start at the bottom. Arrow, -infinity. I go up, 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 up. Looks can be deceiving. It's not 5. Because over here, even though it's below the 5, is an arrow that's still going to keep going up and up and up and up. It's going to go to the right and up. So my range is -infinity to infinity. 6, are we continuous? Are there any gaps? Yep, there's still a gap. Now, if this green function was attached to this blue dot up here, there would be no gaps. You can officially trace it with your pencil without lifting it up, and therefore it would be continuous. All right, so this is still a no. All right, and that wraps up part 2.